In this example, we will be working out a decomposition problem. And the way we know this is, if you notice here, we have one reactant, H2O2, and then we have two products here. So and those are our two products. Now, just like in a synthesis reaction, we're going to go through the same process here. So I'm going to make a T-chart separating my reactants from our products. If you notice now, because we only have one reactant, there's no plus sign, so I'm going to put down my two hydrogens and my two oxygens. And this is where I was telling you it's important that you organize your products how you're going to use them, because if you notice, we have an oxygen as part of water, and we also have oxygen by itself. So we're going to eventually need to take care of both of these products and make sure they're complete and there's nothing extra. So what I'm going to do is I'm going to start by putting my two hydrogens down underneath water, because I know I will use that there. If I place one of those oxygens with those two hydrogens, I have a complete water. And then I'll put that second oxygen over underneath the O2. So if we look at this problem here, I have a complete water, and so that would be considered good. Except for then you come over here to the oxygen, and we need O2, not just oxygen by itself. So in order to do that, I'm going to have to add more reactants. But because it's my only reactant's H2O2, I add the whole thing. Alright, so we have to add two more hydrogens and two more oxygens. You can't just separate that out. So I'm going to add my two hydrogens and my oxygen down below. That gets me another water molecule. And we'll put that remaining oxygen up by our other lone oxygen. That gives us a oxygen molecule. Now the reason why this is you have to add as H2O2 is the only reactant's hydrogen peroxide. We don't have anything else in that beaker. This just happens on its own. So if I want to update my initial problem, it took 2 molecules of hydrogen peroxide to form 2 molecules of water and 1 molecule of O2.